In this video, we're going to start the KutaSoftware Infinite PreAlgebra free worksheet, fractions and decimals. In this first section, we're going to be writing each as a decimal, and we're going to use repeated decimals or repeating decimals when necessary. So in this first part, it's all about converting a fraction to a decimal. And in number 1, I'll show you 2 separate ways to do that. The first way is to think about it like the places of a decimal. So there's the tenths place, the hundredths, the thousandths, the 10,000ths, and so on. So think of this bottom as that potential place. Now, we don't have a fourths place when writing a decimal. We have, again, tenths, hundredths, and so on. And 4 doesn't go into 10, but it does go into 100, and that's 25 times. So if we multiply 4 by 25, we'll get 100 in our denominator. Now, multiplying just the denominator by 25 will change the value of the overall fraction. So whatever we do to the denominator, we also need to make sure we're doing within that numerator. So we'll also multiply 1 by 25, essentially multiplying by 25 over 25, which is multiplying by 1. So 1 times 25 will be 25, and we'll have 25 over 100, which we can write as 25 hundredths, in decimal form 0.25. And that's our solution in number 1. Now there's another way we can think about this. For example, if 4 was not to go into 10, 100, 1000 very easily, we can simply divide, because remember, a fraction, some number over another number, is that numerator divided by the denominator. So let's practice some long division. We'll take 1 and divide that by 4. Now, 4 obviously does not go into 1, so we'll write a 0, and remember to put our decimal point right above where it is. And now we'll put a placeholder 0. Now 4 goes into 10. 4 would go into 10 2 times, and 2 times 4 is 8. So let's subtract 8 from 10. That leaves us with 2. Now, we don't want a remainder of 2, we want to try to get down to a remainder of 0. So let's continue on, putting another placeholder, extending this out a bit, bringing that 0 down. 4 goes into 20 5 times. 5 times 4 is 20. 20 minus 20 is indeed 0. So we get 0.25, which is what we got using the other method for number 1. But let's move on to number 2. In number 2, we have 2 and 3/5. We can think of this as 2 plus 3/5, because 2 plus 3/5 is 2 and 3/5. Now I'll just need to rewrite our fraction 3/5 in decimal form. So this will be 2 point, or 2 and some decimal that I'm going to figure out. Now, lucky enough for us, 5 goes evenly into 10. So 3/5, we can write that, multiplying the 5 by 2, we'll get 10 in the denominator, and multiplying 3 by 2 in the numerator, we'll get 6. This is read as 6 over 10, or 6 tenths. So 2 and 6 tenths will be our fraction converted to a decimal in number 2, 2.6. Feel free to practice some long division and divide 3 by 5 and see if you again get 0.6. Let's move on to number 3. In number 3, we have 5/8, which 8 doesn't go into 10, it doesn't go into 100, it does go into 1,000, but it would be hard to know that just by looking at it. So let's go ahead and calculate this using long division. So we'll take our numerator of 5 and we'll divide it by 8. So 5 divided by 8, 8 goes into 5 0 times, so writing the 0 and carrying down that decimal. So now we'll put a placeholder of 50. 8 goes into 50 6 times. 6 times 8 is 48. Notice if we tried multiplying 8 by 7, that would be 56, which is greater than 50. So 6 is the highest number of times 8 goes into 50. And when we subtract 48 from 50, we get 2. Now we'll put another placeholder and bring down that 0. So we'll see, extending this out, how many times 8 goes into 20. And 8 goes into 20 a maximum of 2 times. So 2 times 8 is 16. So we'll subtract 20 minus 16, that leaves us with 4. And then when we bring down that next 0, I know that 8 goes into 40 evenly, and that's 5 times. So you can see we'll get 0.625, or in other words, 625 thousandths. Let's move on to number 4. Now, number 4 is pretty easy because we've kind of already done this one back up in number 2, except as opposed to 2 3/5, we just have 3/5. So we know that if we take 3/5 and multiply the denominator by 2, we'll get 10 in the denominator. And whatever we do to the denominator, we need to make sure we're doing in the numerator so we don't change the value of the overall fraction. So 3 times 2 will give us 6. So we would read this fraction as 6/10 and write the decimal as 0.6. That's our solution in number 4. Now moving on to number 5. In number 5, we have 7 over 200, or 7 divided by 200. Let's do division first, and then I'll show you another trick. So we'll take 200 and divide that into 7. 200 goes into 7 0 times. 200 goes into 70 0 times. So we'll put another placeholder. 200 goes into 700. That will be 3 times, because 3 times 200 is 600. So we'll have 600. Taking that away from 700 will leave us with 100. But if we add another placeholder 0, bringing that down, 200 goes into 1,000 5 times evenly, because 5 times 200 is 1,000, so we'll get a remainder of 0. So 0.035, or 35 thousandths, is our solution in number 5. Now quickly, I'll make a note of another way to think about this. Although if this is a little confusing, just keep doing the long division method. So remember when I said that we want our denominator to be either 10, 100, 1,000, or so on. 200, we can break that up, dividing it by 2 to get to 100. So if we have 7 over 200 and we divided 200 by 2, we would get 100. But remember, whatever we do to the denominator, we need to do to the numerator. So we also have to divide 7 by 2. 7 divided by 2 is 3.5. That's a decimal in itself. So we have 3.5 divided by 100, so 3.5 hundredths. So that'll be 0. Here's my tenths place, and here's my hundredths place. So 3.5 would start in that hundredths place to give me 0.035. Or, if this is confusing, think about this. We have 3.5 over 100, and remember we don't want this decimal, so multiply the numerator by 10 to get rid of that decimal. Doing so will then, as opposed to having 3.5, we'll have 35. And then whatever we do to the numerator, we have to do to the denominator. So also multiplying the denominator by 10 to give us 1,000. And then read this as 35 thousandths, and there you have it, 35 thousandths. And number 6, we have 8 divided by 33. Now this one's a bit trickier, but follow along and I'll show you what we're to do. So we have 8 divided by 33. So taking 33 and dividing it into 8, 8 divided by 33, 33 goes into 8 0 times. So now we're going to see how many times 33 goes into 80. 33 goes into 80, that'll be a total of 2 times. 2 times 33 is 66. So subtracting 66 from 80 4 will bring us to 70, and then 10 more will get to 8. So that will be 14. 66 plus 14 gets 80. Have a placeholder 0 dropping that down. Now we're going to see how many times 33 goes into 140. 33 goes into 140, that's going to be 4 times. 4 times 33, think about it like this. 33 times 4, 4 times 3 is 12, carry the 1. 4 times 3 is 12 again, 12 plus 1 is 13. So 4 times 33, that's going to be 132, and when we subtract that, we'll get back to what we started with, 8. So now, we're repeating this process. How many times does 33 go into 8? So 8 divided by 33. Since that's what we were at the start, we know that this is just going to keep repeating. So we'll have 0.24, and then we'll get another 24. And if we continue on, you'll notice that we'll get another 24, 24, 24, and so on. 24 repeating. The 24 will keep repeating, so we write it as such. 0.24 repeating, or 24 hundredths repeating. Now let's continue on to number 7. In number 7, I'll give you a hint, we're going to have another repeating decimal. But let's go ahead and stick through that long division. So we'll take 6 and we're going to be dividing 6 by 11. And we know that 11 doesn't go into 6, so we're going to start off with a 0. Making sure we keep track of that decimal point, we'll now see how many times 11 goes into 60, which is 5 times. 5 times 11 is 55. Notice that if we tried to multiply 11 by 6, we get 66, which is greater than 60. So remember, we need to see how many times 11 goes into 60 without going over, and that's 5. So if we take 60, subtract 55, we'll get 5. So we'll bring down that 0. 11 goes into 50 4 times, and that will be 44. So 50 minus 44 will give us 6. Now look, what do you see? We got to stop because we got right back to that very beginning value we tried to do. We tried to divide 6 by 11 and couldn't do it. So this will just keep repeating. So here, now that we've gotten back to the stop, we will be repeating 54 hundredths. So 0.54 repeating is our solution in number 7. Now in number 8, we have 7 over 50. And 50 can easily go into 100. That would be multiplying it by 2. And remember, whatever I do to the denominator, I need to do to that numerator so that I don't change the overall fraction. So 7 times 2 is 14, and 50 times 2 is 100. So reading this fraction, 14 over 100, that's 14 100ths, or 14 hundredths in decimal form, 0.14. We can also think of this as 14 divided by 100. We'll write this 14, and if this decimal point is here, dividing it by 100 will move that decimal point 2 to the left. So then we'll get 0.14 as opposed to having 14. 2 zeros in the 100, we move the decimal place over twice. And I'm just trying to show you many different ways to think about these problems, so use whichever way you're most comfortable with. Or challenge yourself and try these new ways to see if eventually you'll find them easier. Let's continue on to number 9. Number 9, we have a mixed fraction, so I'm not going to touch this 4 at the start. I know it's going to be 4 point some fraction. So 4 and some decimal points after that decimal place. And let's figure out what that is. So I'm going to take 125 and see how many times that goes into 27. So 27 divided by 125. I know 125 doesn't go into 27, so I'll write a 0, keeping my decimal point, and see how many times 125 goes into 270. And that's going to be 2 times, because 2 times 125 is 250. So when I subtract that, I'll have a remainder of 20. And I know 125 doesn't go into 20, so I'll bring down that 0 and see how many times it goes into 200, which is 1 time. So then I'll subtract 1 times 125, which is 125, from that 200. And that will leave me with 75. And I know 125 doesn't go into 75, so another placeholder 0, bringing that down, I'll see how many times 125 goes into 750. So 750 divided by 125, well, I know 125 times 2 is 250, and 250 times 3 gives me 750. So doing a little bit of mental math, I know that 750 divided by 125 will be 6. Because we'll go to 125 to 250, that was times 2. So for every 2, if 250 goes into that 3 times, 2 times 3 is 6. So 0.216 is my decimal that represents 27 over 125. However, we can't forget about that 4. So my final solution is 4.216, or 4 and 216 thousandths. That's my solution for number 9. Moving on to number 10, I have 7/20ths, which thankfully is another easy one. 20 goes into 100 evenly. So let's just multiply 20 by 5. And in doing so, I'll have to do the same to the numerator, multiplying that by 5 as well to get 35, because 7 times 5 is 35, over 100. So this is equal to 35 hundredths, 0.35. Or, just another way to think about it, we can go backwards. As opposed to putting 20 into 100, we can divide 20 by 2 to get to 10. So 7/20ths, we can also write that as dividing each by 2. That'll be 3.5 over 10. And remember, if we're dividing by 10, 100, 1,000, and so on, we're just going to be moving that decimal place over. So I'll take this decimal place and I'll move it over to the left 1, because I have 1 0 within 10. So moving my decimal place to here, I'll now have 0.35. So again, if I have 3.5 and I'm dividing that by 10, that's the same as moving the decimal place over 1 to the left to give me 0.35. Let's move on to number 11, and that'll be on the second page. In number 11, we have 1 over 111. 1 divided by 111. So let's do that. 1 divided by 111. I know that 111 goes into 1 0 times. So putting that placeholder 0, I know that 111 goes into 10 0 times. I know that it goes into 100 0 times as well. So now we'll put another 0 and see how many times 111 goes into 1,000. And that's going to be 9 times. So 111 is going to be 999. So subtracting from 1,000, we'll get 1. And then we can stop right there because we're right back at that beginning value, trying to divide 111 into 1, or 1 divided by 111. So if we were to continue on, we'd put a placeholder here and then bring that down and see how many times 111 goes into 10, which we know is 0 times. Then we'd do that again, which we know going into 100 is also 0 times. Then we do another placeholder, bringing that down, and finally get that it goes into 1,000 9 times. So you can see that it's the 009 that will get repeated. So this is 0.009 repeating. In other words, we can say it's 9 thousandths repeating. 0.009 repeating. Now let's move on to number 12. Number 12 is our last one in this section. And let's go ahead and complete this one using long division. So we'll divide 1 by 125. We know that 125 goes into 1 0 times. So then we'll use a placeholder. We know that 125 goes into 10 0 times, so we got to use that other placeholder. 125 goes into 100 0 times, so yet again, another placeholder. 125 goes into 1,000 evenly. It goes into 1,000 8 times. So our solution, number 12, is 8 thousandths. Another way we could have done this is if we would have recognized that 125 went into 1,000 right away, we could see that 1 over 125, we need to multiply that denominator by 8 to get to 1,000. So that means we need to multiply our numerator as well by 8 so that we don't change the value of our overall fraction. So that would be 8 over 1,000, which we read as 8 thousandths. Now in this next section, we're going to be doing the opposite of what we've just done. As opposed to taking a fraction and writing it as a decimal, we're going to take a decimal and write it as a fraction. And the easiest way to do this is to write the number over 1. So writing the decimal first by a fraction. But remember, we don't want a decimal within a fraction, so let's get rid of it. In order to get a whole number out of 2.2, we need to multiply by 10 to move the decimal place to the right. So multiplying by 10, we'll get 22 in the numerator. But remember, whatever we do to the numerator, we need to also do to the denominator. So we'll also multiply 1 by 10. So we'll have 22 over 10. And this fraction simplifies down. For example, I can divide both by 2. Dividing both the numerator and the denominator by 2, I'll get 11 fifths. Now note that this is an improper fraction because 5 goes into 11 2 times. So 5 times 2 is 10 with 1 remaining. So I can write this as 10 fifths plus 1 fifth, where here is my whole number 2 and here is my fraction. So pulling out an even number of 5s will give me 2 and 1 fifth. So 2 and 1 fifth is my solution. And if you got confused on how I simplified down, I found the greatest common factor between 22 and 10, or what would divide into those evenly, which was a 2. And since I divided the numerator and denominator both by 2, I didn't change the value of that overall fraction. So 11 fifths is equivalent to 22 tenths. But I noticed once I got to 11 fifths, that 11 divided by 5 was going to give me a whole number and a decimal. So I brought out the number that 5 would go into evenly, which was 10, and then I had a remainder of 1. 10 divided by 5 is 2, and then we have 1 fifth. 2 and 1 fifth. Another way to think about this is drop the 2 off in the beginning. So we know that we have some whole number 2. So 2 and 0.2 over 1 is what we need to figure out. Multiplying that by 10 and multiplying our denominator by 10, we'll get 2 and 2 tenths, which 2 tenths dividing each by 2 simplifies down to 2 and 1 fifth. So either way of thinking about that is fine. And note, this is not 2 times 1 fifth, it's 2 and 1 fifth. So let's continue on using this method in number 14. In number 14, again, we're going to have some improper fraction, so I'll pull the 1 out at the start. So I'll rewrite 1 and 6 tenths as 1 plus 0.6. But just as I read it, 1 and 6 tenths, we could simply write that. 1 and 6 tenths. And that would be our solution in number 14. 1 6/10. If you want to see that done out more in depth, we'll have 1 and 0.6 over 1. We would need to multiply both of those by 10, so both the numerator and denominator, to get 6 over 10, which could then be simplified down. 1 6/10 simplifies down into 1, and dividing both of those by 2, 6 divided by 2 is 3, and 10 divided by 2 is 5. 1 3/5 is our solution in number 14. So that's another way to think about how to write a fraction. So in number 15, we would read this as 8/100ths. Here's our 10th place, here's our 100th place. And just like it sounds, this is going to be equal to 8 over 100. Or, if you want to see the multiplication method, we'll take 0.08 over 1, because dividing by 1 does not change the value of our decimal. But we don't want a decimal within our fraction, and in order to get rid of that, we need to multiply by 100. So multiplying the top by 100 and the denominator by 100, we would get 8 over 100. So you can see that's the same thing, or you could just think 8/100ths. However, this isn't simplified, because both are divisible by 2. Well, actually, both are really divisible by 4, because 8 divided by 4 would give me 2, and 100 divided by 4 would give me 25. Although, if you didn't see that it was divisible by 4 at the start, just divide by the first one you see. If you divide both by 2, dividing 8 by 2 and dividing 100 by 2, we would get 4 over 50. And again, both of those are divisible by 2. So divide by 2 again, and we would get 2 over 25. So even if you can't find the greatest common factor between those to divide by at the start, divide by the one you do see and then keep simplifying down. Dividing by the greatest common factor will just get you the simplified one right at the start. Let's go on to number 16. Number 16, you would read this as 27/100ths, or 27 over 100. And so 27 and 100 do not have a common factor. Therefore, 27/100ths is the simplified fraction. In number 17, we have 1 76/100ths. So I'll write this as 1 76/100ths. However, both 76 and 100 are divisible by 2. So let's start there. So dividing 76 by 2 and dividing 100 by 2 will get 1, and 76 divided by 2 is 38, and 100 divided by 2 is 50. Now look, they're still both even, so I didn't pick that greatest common factor. So now I'll divide them by 2 again. Dividing 38 by 2 and dividing 50 by 2, I'll have 1 and 19/25ths, which 19 is prime. 19 and 25 do not have any factors in common, therefore 1 and 19/25ths is my solution for number 17. So really, the greatest common factor was not 2, but 2 times 2, which is 4. So 19 times 4 gives me 76, and 25 times 4 gives me 100. Let's move on to number 18. Now in number 18, we see our first repeated decimal. Which is definitely a little trickier than converting other decimals to fractions. Although, it's not as bad if we were to rewrite this. So we know that the 0.15 is repeated, but I want to turn this into a number that I can actually write as a decimal. So I'm going to take that repeated number and move it over into our whole numbers place. So now I'm going to have 15.15 repeating. So in order to write this as 15.15, or 15 and 0.15 repeating, I multiplied it by, well, I moved the decimal place over twice, so I multiplied it by 100. So 100 times 0.15 repeating will give me 15.15 repeating. Now you may be thinking, this doesn't look like it's getting easier, it looks like it's getting more complicated. So let's just subtract off that repeated decimal. So let's subtract by 0.15 repeating. So essentially, from 100 times 0.15 repeating, I'm subtracting 1 of that given decimal, that repeated decimal 0.15. And look, 15.15 repeating minus 0.15 repeating, well, if we're taking off that repeated stuff, 15.15 repeating minus 15.15 repeating will be equal to 15. So 100 times 0.15 repeating minus 1 of 0.15 repeating will also equal 15. Think, if I have 100 apples and I'm taking away 1 apple, I'm left with 99 apples. So if I have 100 of my repeated decimal and I'm subtracting 1 of my repeated decimal, I'm left with 99 of that repeated decimal. So 99 times 0.15 is equal to that whole number 15. And I'm so close to being done because here is what I started with. 0.15 is equal to, let's just get rid of this 99. And in order to do that, divide by 99. 99 divided by 99 is 1, and 1 times 0.15 repeating is 0.15 repeating. So this is equal to 15/99. And if you want to, feel free to double check with a calculator. But unfortunately for us, this isn't simplified. Both are divisible by 3. So dividing our numerator by 3, 15 divided by 3, we'll get 5, and dividing our denominator by 3, we'll get 33. So 5 over 33, or 5/33, is our solution in number 18. Now moving on to number 19, we have another repeated decimal, but I think this one's a little bit easier. Remember our first step in our previous one was to be able to write this as some combination of itself subtracted from some combination of itself to equal some whole number. So let's start by making this a whole number with the repeated decimal. So moving it over once, that would be multiplying by 10. So we'll have 3.3 repeating, so that's 10 times our given decimal 0.3 repeating, or 3/10 repeating. And in order to get this into a whole number, we need to subtract 1 of our given decimal. So subtracting 3/10 repeating. 3.3 repeating minus 0.3 repeating is that whole number 3. So 10 of our number minus 1 of our given number will give us 9 of our given number. So 9 times 3/10 repeating equals 3. But remember, this is what we started with, so we don't want this 9 here. Let's divide it. Dividing by 9, 9 will cancel out with 9. But whatever we do to this side, we got to remember we do to the other side of that equality. So dividing 3 by 9, we'll get our answer. That 0.3 is equal to 3/9. But 3 and 9 are both divisible by 3. So dividing 3 by 3 we'll get 1, and dividing 9 by 3 we'll get 3. So 1/3 is our solution in number 19. And eventually you'll be able to pick up on some patterns. For example, a 3 repeating is 1/3. A 6 repeating would be 2/3. 2 times that repeated value of 3 would be 6 repeated. Now on to number 20. Remember, we need to write this so that we can get a whole number out of it. And in order to do that, we need to move our decimal place over 2 times to the right. So that's multiplying by 100. So 9.09 repeating, that's the same as 100 times 0.09 repeating. And we want to subtract off that repeated decimal, so subtracting off what we started with. So subtracting, again, 1 of 0.09 repeating. That's going to give us the whole number 9. 100 of some number minus 1 of that same number. Think about it as this: 100 oranges minus 1 orange, because they're like fruits. That'll give us 99 oranges. So 99 times 0.09 repeating is equal to 9. But we don't want this 99 here, so let's divide by 99. Whatever we do to that left-hand side, we got to make sure that we do to that right-hand side in order to keep our equation the same. So 0.09 repeating is equal to 9 over 99. But 9 and 99 are both divisible by 9. 9 divided by 9 is 1, and 99 divided by 9 is 11. So 1/11 is our solution for number 20. Let's move on to number 21. In number 21, we have 7/10 repeating. So what we're going to do is move that decimal place over once in order to eventually create a whole number. So moving it over once, that's the same as multiplying by 10. So we'll have 7.7 repeating minus, in order to make that a whole number, we need to subtract that repeated decimal. So 7 and 7/10 repeating minus 7/10 repeating will give us 7. Now again, how do we get 7 and 7/10? We multiplied our original number by 10. So 10 times 7/10 repeating, in order to get that as a whole number, we need to subtract 1 of that original decimal repeating. So subtracting 1 times 7/10 repeating, that gave us that whole number 7. And again, 10 of some number minus 1 of the same number will leave us with 9 of that number. So 9 times 0.7 repeating equals 7. And this is what we started with, that 0.7 repeating. So in order to make it a fraction, we need to get it by itself. So divide both sides by 9. 9 divided by 9 is 1. So 0 and 7/10 repeating equals 7/9. And that's our solution for number 21. Let's move on to number 22, which will be our last repeated decimal. In number 22, we have 46/100ths repeating. So again, we need to figure out how to rewrite it as a whole number that we can then divide by. So moving that decimal point over twice, we'll get 46 and 46/100ths repeating. So 46 and 46/100ths repeating. Again, that was me multiplying my repeated decimal by 100. In order to get that as a whole number, I need to subtract 1 of that given decimal. So subtracting 1 of my 46/100ths repeating. 46 and 46/100ths repeating minus 46/100ths repeating will leave me with the positive 46. So 100 of that number minus 1 of that number will be 99 of that number. So 99 times 0 and 46/100ths repeating will equal 46. My last step, just divide by that 99. So once we divide by that, we'll move it over and get that 46/100ths is equal to 46 over 99. And both of those do not have a factor in common, therefore 46/99ths is our solution for number 22. Now on to number 23, back to an easy one. This we can read as not the tenths, hundredths, but thousandths. So this we can write as 5 thousandths. 5 over 1,000, which 5 and 1,000 are both divisible by 5. And we know this because 5 goes into any number that ends in 5 or 0. So 5 divided by 5 is equal to 1, and 1,000 divided by 5 is equal to 200. So 1 over 200 is our solution in number 23. And lastly for this video, number 24. And thankfully, we'll end on a pretty easy note. However, before I go through this problem, don't forget to like, subscribe, and share. All likes and subscriptions are greatly appreciated, and just let me know that you're finding these videos useful. So now that you've hopefully done one or all of those, let's finish up with number 24. 24, we would read this decimal as 4/10. So we'll write it as 4/10, which, because both are even, they're both divisible by 2, and 4 divided by 2 is equal to 2, and 10 divided by 2 is equal to 5, because remember, whatever we do to the numerator, we do to the denominator. So dividing each of them by 2 will give us 2/5. So the final solution on this worksheet is 2/5. Continue on to the next worksheet, where we'll now throw in some percents as well. And if you have any questions, please feel free to leave them in the comments below. For more information, go to my website, maemap.com, maemap.com. And I'll also leave a link in the video description below so you know where to find this free KutaSoftware worksheet at.